Welcome. My name is Jose Posada. I'm a senior clinical data scientist working for the Stanford Center for Biomedical Informatics Research and Research IT at Stanford Healthcare. Today, I'm going to be with you on tutorial 4 on Stanford Medicine Tools for Healthcare Data Science. Today, I'm going to present the first part of this tutorial that will be divided in 6 easy consumable parts for you to go through them. In the first part, we're going to cover Stanford Data Risk Classification and our secure high-performance computing center. The Stanford Data Risk Classifications were covered in a prior tutorial, but today we're going to focus on the high risk category. So let's get started with some refresh questions. What are the following answers are true about high risk data at Stanford? In this case, the answer is all of the above, because high risk data, the protection of high risk data is required by law. And every high-risk data is classified by Stanford even have some reporting duties in case there is a breach on the use on the data. So it's very important that we remember this. The protection of this data is required by law regulation, and the loss of confidentiality of this data actually may harm Stanford financially or its reputation. With that, we want to introduce Nero, because high-risk data requires special measures to handle. And one of the things we are striving to ensure that you have is a high-performance computing center that is secure and that fulfill the minimum security requirements that we at Stanford have set for dealing with high-risk data. And the important part of that is that it's a fully managed service, so you don't really need to stand up your own servers or buy all that infrastructure, because it's already provided in a centralized way. So Nero is that. Nero is the answer for your computing needs when you need to handle high-risk data at Stanford. And then what is Nero? Nero is a platform, it's a high-performance computing center designed and built to ease the process to use big data analytics and big data frameworks and softwares that are heavily used when dealing with high volumes of data. And not just that, when dealing and use by an extensive set of data scientists, statisticians, and for example, here you will be able to access the interface through Jupyter Notebooks. You will be able to use the state-of-the-art deep learning packages like TensorFlow or PyTorch, and you will be able to even use Docker containers in the form of Singularity containers to launch your jobs in the scheduling system that is called Slurm. You will have access to not just CPU and large amount of RAM, but you will also have access to GPU, so you can train efficiently the state-of-the-art AI for your research needs. It's meant to be scalable, secure, and it's meant to be easy to use. So what is the Nero workflow for the STAR OMOP BigQuery dataset? At Research IT, we have a set of Google Cloud Platform GCP projects where the data resides. So how do we give you access to a project that is fully managed by us? This is easy. First, you need a GCP project of your own. Those GCP projects are managed by the Nero team in a way that they also fulfill all the security requirements we at Stanford need for those projects. From that GCP project, we are setting up what we call a bridge. That bridge is no more than an allowance list for accessing our data from our own projects. It's important to notice that you have read-only access, but you can connect, read, and even generate secondary tables out of the primary data you have access in the GCP control projects by RIT. From Nero GCP, and from Nero, you will have access to two main computing interfaces. First, you will have access to an on-premises computing interfaces when you will take advantage of a fully subsidized computing environment for your research needs. However, if you want maximum flexibility and you want maybe more capacity and on-demand computing, you can also stand up computing in a computing environment in your own GCP project. A small recap of what we've been talking about, the data sets we have access. First, we have a star OMOP identified. That data set is high-risk data set that usually can only be accessed for a subset of patient records given a very specific IRB that will allow you to see some of the items that are in that data set. Second, we have a star OMOP DID. It's still a high-risk data set because it may contain incidental PHI. Incidental PHI, in brief terms, is that even if we have a system that removes 99.99% of all patient information, there is still a very minor risk that patient information leak through. And because of that, we are still considering that data set high risk. That data set contains clinical notes as well as concepts derived from clinical notes. In this tutorial 4, we are going to focus specifically on the clinical notes and the concept derived from clinical notes, how to access that data from Nero, how to use it, and how to build cohorts using that data. Third, we have star OMOP DID Lite. That DID Lite contains all data that is in star OMOP DID, but clinical notes or any free text field. So all free text fields from that data sets are removed, which makes that data set a medium risk data set. Then we have the 1% DID Lite, and that 1% is created for your convenience so you can have a smaller data set to refine your queries, so you can control your costs when querying to BigQuery, and you can ease the process of managing your learning curve into BigQuery. Then we have a star Stride. Stride is a data model that was created by Stanford even prior I2B2 existed. This data set has a idiosyncratic data model that is only true for Stanford, and it can be accessed through the chart review tool and the cohort tool. Then we have a star Tahoe that was a medium risk data set that is no longer supported. So from the one of you that are listening to this video, star Tahoe is now deprecated. With this, we finish the first part 1 of tutorial 4.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.